We're going to start number 5 here. And one of the things you want to keep in mind as you go through each of these Lewis structure problems is that you really do need to use your 6 steps on your notes. If you don't use those, you're not going to be able to function. You're just going to be in that situation, which I've described before, where like, I don't know what to do. It's like, oh, yeah, you do. I'd tell you the exact 6 steps that you got to take. Austin, I'm looking at you. Okay. So when you don't know what to do, you need to look at those 6 steps. So does everyone have those 6 steps out on the desk? Yes. Are you lying to me? Yes. Okay. So I have those 6 steps out. We're going to start with A. First thing we're going to do, we're going to identify we have a nitrogen, we have 3 hydrogens. Those are the atoms that we have to use and account for, because that's what the formula says. Looking at the periodic table, either remembering our trend with regard to number of valence electrons and main group number, or simply referring to the table that's in your notes, we see that for step 2, nitrogen has 5 valence electrons, and then each hydrogen is bringing 1 valence electron to the party. Now we have to go to the next step, which is create a skeleton structure. That's going to involve us picking what's going to be the central atom. Now, the first thing you always want to look for is carbon. Is carbon present here? No. So the next thing we're going to do is we are going to look for the least electronegative element. So who has the periodic table with electronegativity values open? Okay. Who has that? Who has it? Who has it? What's less electronegative? Hydrogen or nitrogen? Okay, it's a 50-50 guess. Look at your periodic table with the electronegativity values. It's in your notes, Austin. Okay, good. Yeah, it's hydrogen. Good job. Good. You're amazing that you read something that I printed for you. But here's the thing. Can hydrogen be the central atom? No, it cannot be. So it has to be nitrogen. So even though nitrogen is more electronegative than hydrogen, it has to be the central atom. So I have nitrogen there with its 1, 2, 3, 4, 5 valence electrons. Now, looking at this diagram, I see that there are 3 unpaired valence electrons. 3 unpaired valence electrons means the potential for 3 bonds. Right, because each of these unpaired electrons can be shared with some other atom. For example, a hydrogen. Or maybe a hydrogen right here with its 1 valence electron. Or a hydrogen right here with its 1 valence electron. Next up, you can see which electrons are going to be involved in making a bond. Okay. The electron that this hydrogen brought to the party, and then this unpaired electron from nitrogen, and et cetera for these 2 other hydrogens. So at the end of the day, when we go to rewrite this or represent it using lines to represent our single bonds, we have this structure right here. This is ammonia, by the way. Anyone ever clean floors using like some sort of ammonia-based cleaner? It has like a really weird, bad smell. That's this. That's this. Oh, please do. He said very sarcastically. All right, moving on to B, H2O. I have an oxygen with 1, 2, 3, 4, 5, 6 valence electrons. And I have 2 hydrogens, each with 1 valence electron. Now, I'm in the same predicament as I was in for A. There's no carbon, and so the least electronegative element is hydrogen, but hydrogen can't be central, so that leaves me with oxygen as my central atom. 1, 2, 3, 4, 5, 6 valence electrons. I have 2 hydrogens over here. I'll place those right next to the unpaired valence electrons from oxygen. And then you can see that these are the electrons that are going to form that covalent bond. What was that? The lines represent bonds, yes. They represent 2 shared electrons. There we go. That's water. That's what water looks like. C, looking at methane. This is the stuff that's in your farts. Yeah, this is natural gas. This is C. 1, 2, 3, 4 valence electrons. And then I have 4 hydrogens, each with 1 valence electron. So that's what I have to account for. Now, I do have carbon here, so I'm going to use that in the center of my skeleton structure. And then I'll simply surround that carbon with hydrogens that are all bringing 1 valence electron to the party. There's a bond, there's a bond, there's a bond, there's a bond. And so my finished product for methane looks like this. And that's methane. Moving on to D. We're going to get a little trickier here. There are going to be some problems that are going to be solved by using multiple bonds. So that's my hint, multiple bonds. So I have 2 carbons. So that's going to be the central atom in my skeleton structure, right? But there are 2 of them. So a lot of students ask, well, which carbon do I use as central for this structure? And the answer is quite simple. It's both of them. Remember last year in biology, you guys learned about the carbohydrates, you learned about fats. That all started with a carbon chain. Carbon chain. That's Kelvin. So I have my 2 carbons. I'm going to put them in the middle. Write down their 4 valence electrons so I can be aware of how many bonds they need to have. Notice that each carbon has 4 unpaired valence electrons. That's why, or that's how we know that it wants to form 4 bonds. I have 2 more hydrogens left. I'll just stick those on the outside so they're not confused as being central, because they're not, with their 1 electron. So I can tell that that's going to be a bond and that's going to be a bond. Well, I can also tell that this is going to be a bond as well. But looking at each carbon, I see that there aren't sufficient bonds for each carbon. Each carbon only has 2 bonds. This carbon has that bond and that bond. This carbon has that bond and that bond. I'm too short. I'm 2 bonds short. But if you guys are noticing, we still have some unpaired valence electrons. So I can form a bond between these 2 electrons in carbon and then these 2 electrons in carbon. So I have 1, 2, 3 different bonds between the 2 carbons, a total of 6 shared electrons. That is a triple bond. So I'm going to have carbon, carbon, a triple bond, and then my 1 hydrogen. All right. That's C2H2. And then lastly, E, again, we have a carbon, 1, 2, 3, 4 valence electrons. I'm going to lay down these hydrogens with their 1 valence electron, and how about my oxygen with 1, 2, 3, 4, 5, 6 valence electrons. I can know that, okay, that's a bond, that's going to be a bond, that's going to be a bond. But look at this carbon, only 1, 2, 3 bonds. And then, for that matter, oxygen here only has 1 bond. That's not satisfying, or at least for them. You don't care. But notice I still have unpaired electrons. So between oxygen and carbon, I can create a second bond, and now all of the electrons are paired. So as a result, my final structure don't forget the lone pairs. They're not too important to us for right now, but they will be in the future. And that is E.